ladies and gentlemen. So today we are taking a look at 5.2, multiplying and dividing rational expressions. The warm-up for today is to simplify these four problems. I know the third one is covered by my video right now, but I'll move it in just a moment. So this is really just making sure that you are mindful of some of our exponent rules and simplifying fractions, because we're going to be doing quite a bit of that today. So taking a look at the first one, x to the fifth divided by x squared. When you're dividing things with exponents that have the same base, you subtract those exponents. So the difference between 5 and 2 is x cubed. And the reason why this works is because x to the fifth is like 5 x's being multiplied together, and x squared is like 2 x's being multiplied together. So if I do some division, right, where I divide out those common products or those common factors, I will have two sets of these x's divide out, leaving me with 3 x's being multiplied. So it would be like x cubed over 1, or just x cubed. Taking a look at the next one, 24 divided by 9. 24 and 9 are both divisible by 3, so that's going to leave me with 8/3. Taking a look at number 3, x to the fourth times x to the seventh. X to the fourth is like 4 x's being multiplied together, and then an additional 7 x's being multiplied together leaves us with a total of x to the power of 11, because the product property with exponents is that you add those exponents together. Combining numbers 1 and 2 from this warm-up, I have 3x squared divided by 6. Well, the 3 divided by 6 reduces to 1 over 2. Now if we focus our attention to the second part of this, x squared over x is going to reduce to just x, right? Because originally there was 2 x's being multiplied together in the numerator, but the denominator says we divide out one of those x's, so we're just left with x. You could also approach it as we have x squared divided by x, and if you subtract those exponents, you'd be left with x to the power of 1 in the numerator. So you could write this as 1/2 x like this, or you could write it as 1x over 2, or just x over 2. So today we're looking at multiplying and dividing rational expressions. A rational expression is something that we're going to define first, and then we'll get into some multiplication and division. So what is a rational expression? It's a quotient or a division of two polynomials. So an example would be x squared plus x all over 2x. That would be a rational expression. And just like when we simplify fractions by crossing out common factors, we're going to do the exact same thing with rational expressions. So here we go. Let's get started. We want to simplify and then identify any x values for which the expression is undefined. So we'll get to the second part of these instructions after we do the first part. So the first part says to simplify. Now when you see instructions that say simplify, this is the expectation. We're going to reduce this fraction down. So if we look at this fraction, I have, looking at just the constants or the numbers, I have 10 over 6. Now, the fraction 10 over 6, 10 and 6 are both divisible by 2. So that will leave me with 5 over 3. I'm going to do some color coding with the highlighting here just so you can kind of see what's happening. So 10 over 6 reduces or simplifies to 5 over 3. Then we have x to the power of 8 divided by x to the power of 4. If I subtract those exponents, 8 minus 4 is 4. So I'm left with x to the power of 4 here. And again, color coding just so you can see how that's working out. Now I know x to the fourth is going to go in the numerator or the top of this fraction because when you look at the original problem, the larger exponent was in the numerator. If the larger exponent had been in the denominator, then when I find the difference of these fractions, I will put that variable with the exponent in whether in the numerator or denominator, depending on where the original larger exponent was located. So you'll be getting some practice with that once we move on to some future problems. So the simplified version of this, when the instructions say to simplify, is this, 5x to the fourth divided by 3. This is what I mean by simplify, which is not a lot of work right now because we just have single-termed expressions in the numerator and denominator. But when I say simplify, I'm really saying reduce the fractions. Divide out any common factors that you can. The second part of these instructions say to identify any values of x for which the expression is undefined. So remember, we're dealing with fractions here. And a fraction is always undefined when you're dividing by 0 because you're not allowed to divide by 0. Well, if you look at the simplified version of this fraction, we would never be dividing by 0 because the denominator is just 3, and 3 is not 0. But what we have to be careful of is that when we're dealing with problems like this, we need to look at the original denominator and figure out what values of x would make that denominator 0. So we need to look at the 6x to the fourth. And we have to kind of pull this off to the side and say, okay, well, this can't equal 0. So if I solve for x, what value can x not equal? Because it would give me 0, and that's not okay. That would make it undefined. Well, I have 6 times x to the fourth. X to the fourth means I have x being multiplied by itself 4 times. So 6 times x times x times x times x. Well, the only way you can multiply 5 things together and get an answer of 0 is if the thing you're multiplying by is 0. So this single-termed piece, where all the pieces are being multiplied together, when we say that that can't equal 0, well then that means x can't equal 0. So when it says identify the values for which the expression is undefined, we say, well, the expression is undefined when x is 0, so therefore x is not allowed to be 0, or else we would get something that's undefined in the original fraction. I know it's not there in the simplified version of it because we reduced out common factors, but it is there in the original, so we have to make note of that.